Alright, so for our goal for this lesson is we are going to solve a quadratic equation by factoring. Now, this will not work every time, and we'll talk about specifically when the best times are. But as we work through this lesson, I want you to be thinking about why we use the zero product property when we solve quadratics by factoring. So how does that play into the process? So we have 5 ways that we can solve a quadratic. We have graphing, factoring, square root, quadratic formula, and completing the square. And so far we've talked about graphing, we've talked about square rooting, and quadratic formula. So we're going to focus today in on factoring. All of these methods will get you to a correct answer. There are certain times we've talked about when square root only works when I don't have a b term. And factoring will only work if the trinomial is factorable, but graphing and quadratic formula will work every time. So by the end of this lesson, you should be able to take a trinomial that looks like this and be able to factor it and solve it using that method. Alright, so let's start with this, a quick review. So what were the steps for graphing a quadratic equation? So go ahead and pause the video, and I'd like you to graph this quadratic and see what the solutions are. Alright, so hopefully you were able to remember that when we're graphing, we find the vertex using the axis of symmetry first, so the opposite of b over 2a, and then we know that the x value is going to be -1 of the vertex, so we plug it in to find out the y value, and we found that was -9, so my vertex was at -9. My a is 1, so I follow the normal pattern, so over 1, up 1, over 2, up 4, over 3, up 9. And the reason that I didn't just stop with those 5 points is because we're looking for the solutions, and I know that the solutions are when the quadratic crosses the x-axis. So I kept going until I found those solutions, and I found those solutions to be x equals -4 and 2. And then what is the y value at those solutions? So that is always when y is 0, because the x-intercepts are when y is 0. And that's going to be important when we talk about why we put it into standard form. Alright, so I want you to take a minute, pause the video, and I'd like you to solve these equations for the variable that is asked for. So obviously in the first one, x is going to be 0 because 5 times 0 is 0. K is going to be 0 because 4 times 0 is 0. But if I have x and y, I'm multiplying two unknown numbers together and I get 0, then one of those numbers has to be 0 because there's no way I can multiply two numbers together that are not 0 and get 0. Now, I don't know if x is the 0 or if y is the 0, but I do know that if two numbers are being multiplied together and their product is 0, one of them has to be 0. So we call that the zero product property. So if the product of two or more numbers is 0, so if I multiply x times y together and I get 0, then one of those numbers must be 0. The zero product property is what we're going to use when we're factoring, because then when we factor, we get 2 or 3 binomials or monomials being multiplied together, and they equal 0 because we're looking for the x-intercept. So just like if a times b is 0, then a has to be 0 or b has to be 0, we're going to apply that to when we're dealing with factors of a polynomial. If a times b, or one number times another number, is 0, then that first binomial must be 0 or the second binomial must equal 0. Alright, so when we are solving quadratics by factoring, notice that this is only available if the quadratic is factorable. So generally, it's going to tell you to solve by factoring, but if it doesn't, there are rare occasions when I would actually choose to solve by factoring if I was given a quadratic that wasn't in a pretty basic form. So we're going to talk more about that. But here are the guiding questions that I use when I'm thinking through solving quadratics by factoring. One is the equation in standard form. So again, we need it set equal to 0 in order to use the zero product property, which is the whole purpose of solving by factoring. Can I factor GCF? We always start that. Can I factor the trinomial? Have I set each monomial or binomial equal to 0? And what are the solutions to those equations? So let's get started. So these first two were intentionally already factored because I want us to focus on ensuring we can use the zero product property. So in the first one, the first questions are set equal to 0, yes. is there a monomial that can be, or is there a GCF, and can I factor it? These are already factored. So I already have two linear terms, so I can't factor it any further. And so I know that this number times this number is going to equal 0. So if two numbers are being multiplied together and their product is 0, that means one of the numbers must equal 0. So either 3n minus 2 has to be 0, or 4n plus 1 has to be 0. And now I just solve a simple equation. So I'm going to add 2. So I get 3n equals 2, divide by 3, and I end up with n is either 2/3, so that root is at 2/3, so it's crossing the x-axis at 2/3, or subtract 1, divide by 4, and I get n is negative 1/4. So these roots are crossing at fractions, which can happen. So if I think about what that looks like on a graph, this is going to cross at 2/3, so about right there, and at negative 1/4, so about right there. So I've got this quadratic that's really, really, really skinny, and that's what it's going to look like on a graph. So go ahead and pause the video and try example 2 on your own. Alright, so hopefully you were able to see that m is either equal to 0 or 3. So in terms of a graph, when y is 0, the x value, or the m in this case, is going to cross at 0 and 3. So that's how we use the zero product property when we're solving quadratics by factoring. Alright, so let's actually now start from the beginning. So example 3 says x squared plus 9x plus 18 equals 0. So my first question is the equation in standard form, which I see that it is set equal to 0, so I'm good. And my next question is, can I factor a GCF? So when I look at this, the a is 1, so there's no number that I can take out. And they don't all have variables, so there is no GCF that I can take out. So then my third question is, can I factor the trinomial? Alright, so go ahead and pause the video, and I want you to factor this trinomial. Alright, so hopefully you were able to factor this and get x plus 3 and x plus 6 equals 0. So if you did not get x plus 3, x plus 6, go ahead and look back at my work and see if you can figure out where your error was. We're not going to spend a lot of time on factoring because that's a skill you need. Alright, so from here, once I have determined that I can factor the trinomial, have I set each monomial or binomial equal to 0? So if this times this is 0, then one of those things has to be 0. So either x plus 3 equals 0 or x plus 6 equals 0. So then I just need to find those solutions using basic math. So I'm going to subtract 3 from both sides. So x is negative 3 in this case, or subtract 6, and x is negative 6. So my solutions are, for this quadratic, x is negative 6 or negative 3. And what that means in terms of the graph is those are my x-intercepts. So it's crossing over at negative 6 and at negative 3. Alright, so example 4. K to the third equals negative 4k squared minus 4k. So is the equation in standard form? And we always want to keep our largest largest power, so k to the third, we want to keep it positive. So I'm actually going to move this stuff over here. So I've got k to the third plus 4k squared plus 4k equals 0. So then my next question is, can I factor a GCF? So I noticed that they don't all have a number larger than 1 in common, but they do all share a k. So I'm going to take out a k, and what I'm left with is k squared plus 4k plus 4, and that is equal to 0. Alright, so I'm going to go ahead and I'm going to highlight this so I don't forget about it in the end. So then my next question is, can I factor the trinomial? So go ahead and pause the video and factor k squared plus 4k plus 4. Alright, so hopefully you were able to factor it and get k times k plus 2 times k plus 2 equals 0. I could have written this as k plus 2 to the second power, but I don't want that right now. So then have I set each monomial or binomial equal to 0? So in this case, I have 3 numbers that are being multiplied together, and the answer is 0. So either k is going to be 0, or k plus 2 is going to be 0. And because I have 2 of them, I don't need to write it twice because I'm going to get the same answer. So k plus 2 or k equals 0. And so once I solve those out, I end up with k is either -2 or k is 0. Alright, so for example 5, I'd like you to pause the video and try this one on your own. Alright, so as you work for this problem, hopefully you were able to find that my roots are at -4/3, so just a little bit smaller than -1, and 4. Alright, so now that we've used factoring, it's pretty straightforward. When would I ever use factoring? Because we said it doesn't necessarily work all of the time. So I would generally stick to using factoring when either A is 1, or I can see that it's easily factorable. So to be completely honest, if I were solving a quadratic and I didn't know what it looked like exactly, I would rarely use factoring unless I saw that A was 1 and it was pretty straightforward. Now, you do need to know how to use this process because sometimes they'll say use factoring to solve, and so you need to be able to use that process. But factoring is not one of those that I'm going to naturally do unless I see that A is 1 and it's pretty easily factorable. Alright, so I want you to pause the video. What are 3 errors you think students tend to make when solving by factoring? So what are some errors that you think or you did make? What makes sense to you, and what do you need to remember about solving by factoring? So you need to pause the video and have an interaction. So our objective of solving a quadratic by factoring, we can do that using these sub-objectives. So make sure that you understand every piece of it and identify the places that you might have questions or are confused. All right, I'll see you later.